Bismillahirrahmanirrahim. The topic of our project is use of recycled aggregates in concrete for silica-fume and nano-graphite. Our group supervisor is Mem Shazadi Iram and group members are Zaid Sabir Rana, Osama Sikandar Raja and Muhammad Abdullah Khan. Introduction. The world is growing at a very fast rate. This effect of rapid urbanization is also seen in construction industry. Concrete is the favorite choice as a construction material among civil engineers around the globe for decades. It is preferred for its better performance, longer life, and lower maintenance cost. To achieve rapid urbanization, every year smaller structures are demolished and newer and bigger ones are constructed. All over the globe, the construction industry takes 50% of raw materials from the nature, consumes 40% of total energy, and produces 50% of total waste. However, with urbanization comes the moral responsibility of sustaining the environment. Hence come forth the use of recycled aggregates. The first step in production of recycled aggregates is to determine the quality of source concrete. Properties and records of source concrete like strength, durability, and composition are looked into for this. Then the breaking of concrete, removal of containments like reinforcing steel, foundation material, asphalt concrete shoulders, and soil is done. And lastly, the simple process of crushing concrete into specified size and quality. Problem statement. Main problems that are arising are decay of natural resources, which is one of the biggest challenges to sustainable environment, loss in economy because of waste concrete, and dumping of waste concrete. Concrete is main material used in construction, and after demolishing of a structure, concrete is often dumped on land and is not used for any purpose. This also affects the fertility of the land. Objectives. Main objectives of this project are to utilize the waste concrete in form of recycled aggregate in concrete, recycling of concrete by using different proportions of aggregates, to compare properties of normal concrete with recycled aggregate concrete, addition of silica fume and nano-graphite to enhance the mechanical properties of recycled aggregate concrete. Socioeconomic benefits. Use of recycled aggregates reduces the amount of natural aggregates to be created, hence less evacuation of natural resources. Research has however shown a reduction in construction cost if recycled concrete aggregates are used. It reduces the need for new landfills and hence saving more cost. It is also environment friendly and creates more employment opportunities in recycling industry. Methodology. Following is the flowchart that shows the methodology of our project. We made 4 cycles and targeted strengths are 3000 psi and 6000 psi. In the first cycle, natural aggregates were used, while in second, third, and fourth cycle, composition of recycled aggregates were 25%, 50%, and 75%. Furthermore, the addition of silica fume and nano-graphite. Tests to perform. Several tests were conducted to determine the properties such as compressive strength test, tensile strength test, flexural strength test, freeze and thaw, chloride penetration, and acid resistance. Materials used. Main materials used were cement, sand, and aggregate. Furthermore, silica fume and nano-graphite were also used. Silica fume is available in both wet and dry form. They are added to concrete in composition up to 15% of the weight of cement. They increase compressive strength of concrete and durability of concrete. Nano-graphite. Nano-graphite are added to concrete in composition of 0.5% to the weight of cement. They increase compressive strength by 15%, frost resistance by 2 times, and heat resistance by 4 to 5 times. Since the use of recycled aggregates and the addition of silica fumes causes the water requirement to increase, so superplasticizer is also used. The superplasticizer that we used was Sika Viscocrete 3110 superplasticizer. It is third generation superplasticizer. Now let us go through a demo of our project. First step is the procurement of material such as cement, sand and aggregates. The required quality of aggregate, sand and cement is quantity is weighted and poured into the mixer. The oiling of molds is then done. Mixer is started and calculated amount of water is added in it. And when ready, the mix is poured into the molds and left for 24 hours to dry. After demolding, curing is done and the tests are performed. And after that, molds are broken in order to get recycled aggregates. And same method is repeated with different composition of recycled aggregates. We used sieve analysis to get desired size of our aggregates. This was all about our project. Thank you.